Okay, now we're going to go through the test revision. The first question is just expansion, and that uses FOIL, first outers, inners, last. So we've got here, if you multiply the two firsts together, you get 2x squared. You do outers and inners in your head together, so you're getting minus 3x plus 12x, so that's 9x. And if you do the last, 6 and 3, you get 18 plus and minus, so that's FOIL. Do FOIL with this one here. This one you can actually, because it's a squared factor, you really got x take root 2 multiplied by x take root 2. If you FOIL that, you'll get this. Notice the outers and inners is double the product of the two terms. So you could use the shorthand way of doing it, which is perfect square. A plus b squared is equal to a squared plus 2ab, double the product of the two terms, plus b squared. Or you could use the FOIL system with the two brackets. The third one is also a perfect square, but we just add on one after we finish that. So 1 plus 25 giving us our 26. Factorising is going back the other way. So this is a difference of two squares. The difference of two squares is this rule: a plus b times a minus b is equal to a squared take b squared. That's the difference of two squares, and they're alternating signs and symmetrical like that. So 3x squared, so that's equivalent. Well, first thing we do to make this a little bit simpler is we can take out a common factor of 3. So 3 is brought out of that, which is divided out of that, and so you're left with this. And then this is the difference of two squares, x squared take 3. So x squared take 3 is the same as x squared take root 3 squared. That's the difference of two squares. So it's x take root 3, x plus root 3. Or you could use just the general FOIL concept in reverse. Now that equals 0, so when the first bracket 0, you get plus root 3. When the second bracket 0, you get minus root 3. This one here in part B, you can't take out a common factor, so you've got to FOIL it straight off. The first comes from 3x and x. The last, you have to do it 7 times 4 such that the outers and the inners give minus 5x. Now reading off the two brackets, we can see that in this first case x is minus 7 on 3, that'll make that 0. In this case x equals 4, that'll make that 0. These are called x-intercepts, or in this case they're solutions of the equation. This one here, we need to get rid of fractions, so to get rid of divide 3 we're going to times 3 right through. So timesing the left by 3 and the right by 3 is equivalent to timesing all the terms by 3. So you'll get 3x squared, 5x and 2. Take 2 on the other side, make it equal to 0, and then FOIL it. And so this bracket gives x as a third, that bracket gives x equals minus 2. Solving this equation using completion of square, because you can't FOIL that. It's too hard to put it into two brackets. So completion of square is you add on half the coefficient of x. The coefficient of x is minus 2/3. Half of that is going to be a third. So you add on minus a third squared, and you take off minus a third squared. Now the squared will make this minus positive, will make that minus positive, but you've still got this plus here and this minus here, because you're plussing on something and you're subtracting off the same something, so you're not changing the equation. But the reason we add on half the coefficient of x is because it's the opposite of the perfect square rule. The perfect square rule being a plus b squared is a squared plus 2ab plus b squared. Notice when we go this way, we are doubling it, but if you go the other way, you have to halve it. So that's why we're adding on half the coefficient, because we're actually going to force those three terms to be a perfect square. If you expand that out, you'll see that you get those three terms. Now we collect these two fractions using common denominator. So 1 or 9, and then we're going to convert the 3 to be a 9 by timesing the top by 3 and timesing the bottom by 3. And then minus 1 on 9 minus 12 on 9 is minus 13 on 9. Take that on the other side, so it's positive 13.9. And then you square root both sides, so you've got plus or minus, and take the third over the other side. So there are two x-intercepts, or solutions to the equation. Whenever you have surds, they always appear in conjugate pairs, because, for example, if you've got something like this coming down, this here is a third plus the surd, and this one here is a third minus the surd. So that means that in between, this is x equals a third, because you've got a third plus something and a third minus something. Quadratics are symmetrical, so it's always like that. Alternatively, we could use the quadratic formula to get the same answer. The original equation is here, so there's your a, b and c written over here on the side. Applying it to the formula, minus b plus or minus the square root of b squared take 4ac over 2a. This one under the square root sign is called the discriminant, or triangle, that's the discriminant. Plugging in the values, you get 2 plus or minus root 52 on 6. Now we want to actually cancel this down, so we're going to actually convert that into 4 times 13. The reason 4 is a good one to choose is because we can square root 4. For example, we wouldn't want to put this into, say, 2 times 26, because we can't square root 2 and we can't square root 26. So we choose 4 and 13. Now square root of 4 is 2. We could put the 6 as two separate fractions on the denominator. That cancels down to be a third, and that cancels down to be a third, and we get the same answer here. Is it possible to solve this using graphics calculator? Yes, but we're not going to get these surd values. We're going to get decimal answers, which aren't as accurate. We can do that like this here. You'd put it into y equals, you put in your function. Now in this case, the function is 3x squared take 2x take 4. So you put here 3x squared. I'll just unhighlight this one, I may use that later in the test. So we got 3x squared, take 2x, take 4, and we do zoom fit. And we want to find the x-intercepts. At the moment we need to change the window to get it into range. So we'll go, instead of going out to 35, we only need to go to 5. And the y max is way too big. We can bring that right down to, say, 40. And we could actually see more of the y minimum, so say minus 10. And have a look at what this rescaling does. Now we want to get the two x-intercepts. We know that's a third plus root 13 on 3, and that's a third minus root 13 on 3. But when we do second calc, it'll give it as decimals. So we want to get 0, and it asks to go to the left of one possible solution, then go to the right, then guess, and so it's minus 1.86. So this value here is minus minus 0.86. is the same as a third. Take root 13 on 3, and we can get the other one as well. Okay, now we're going to look at this graph. I've actually added in a letter here, just to make it force people not to use graphics calculators but to do this algebraically. Now to get the x-intercept of this, you can get the 0 of this factor, which is 2. To get the 0 of this factor, it's 2a. When x is 2a, that will be 0. So these are the two x-intercepts. So you could consider something like this. It's going to cut at 2 and the other one is 2a. Don't confuse that a with the a that normally sits out the front. I just put in a random letter, then it could have been p or anything. State the equation of the axis of symmetry. That's the bit that goes through the middle. That's the average of the two x-intercepts. So if you add the two x-intercepts and then divide by 2, you're averaging them. So that will give a plus 1. That's your axis of symmetry. Find the coordinates of the vertex. Well, the vertex is here, and that lies on the axis of symmetry, so we know the x-coordinate. It's a plus 1, but it's a plus 1 comma something. We need to know the y-coordinate. To find the y-coordinate, we substitute the x value into the function to find the corresponding y value. So a plus 1 gets substituted into here and into here. So it's 2, a plus 1 minus 2a, a plus 1 minus 2. Expanding, we're collecting like terms. A take 2a is minus a, and 1 take 2 is minus 1. Now we could simplify this a little bit further. We could say, well, that looks similar, but we need to reverse these around. Neat little trick to reverse things around. You can take out a minus sign. You're taking out minus 1 really. So minus 1 times a is minus a, minus 1 times minus 1 is positive 1. It just flips those two around when you multiply by a minus or divide by a minus. So now those two brackets are the same, we can change them into a perfect square, and the minus goes with the 2. So that's just a little bit shorter writing that than it is writing this whole thing here. But that's not necessary. So now I can find the y-intercept when x is 0. That's the definition of y-intercept. So you put 0 where x was, and expanding, multiplying that out, you get 8a. So putting all that together on a graph, we can see we've got the y-intercept, the x-intercept there and there, the y-intercept there. This is your axis of symmetry, and this is your vertex. Okay, now using the discriminant. Discriminant is the bit underneath the square root sign of the quadratic formula, which is b squared take 4ac. And if it's positive, then we have two real roots. If it's negative, obviously you've got the square root of a negative number, we have no roots. And if it's 0, then we'll have one repeated root, because it comes from minus b plus or minus the square root of the discriminant over 2a. So if that's positive, we have plus or minus a positive number. If it's negative, we have plus or minus an error. If it's 0, then that wipes off, this whole term, and so you only end up with one answer, which actually happens to be the vertex x-coordinate, because the vertex touches. So all you need to do is to have one of those three cases. Write that down. So here it's positive, so it's the two real distinct case. This one here, it says the constant term was free to change. So instead of having the 3 there, we have just c in general. Then the b squared take 4ac is 25 take 4a, and we leave that as an unknown. It's not 3, it's c. So there's our discriminant. Now we want it to be no real roots, so we need this to be negative. So when the discriminant's negative, that means 25 take 8c is negative. We add 8c to the other side and divide by 8, and so if c is bigger than that number, then we have no solutions. And likewise, if it is smaller than that number, then we'll have 2 solutions, and if it's equal to that number, we'll have 1 solution, the repeated touching case. Now when you do this less than, greater than, just be aware you do not change the sign unless you multiply or divide by a minus. So for example, if you had -8 is less than C, and if you times, well, let's say put a minus there, if I want to know what C was, I have to times by -1, in which case I swap the sign around, so C is smaller than -8. So only when you multiply, divide by a minus number. Here we were adding that to the other side, so you don't change the sign around, and we were dividing by a positive number, so you don't change the sign around. 6, 2 quadratics, we need to find the equation. You start off with general form. Well, it's got 2 factors come from these 2 x-intercepts, 1 and 3. So there's x take 1 and x take 3. Put a general A out the front because that determines the width of the graph. Doesn't affect the x-intercepts. To find this unknown A, we substitute in this point here, 0, 4, the y-intercept. So 0 goes where x is, and 4 goes where y is. If you go through that, you'll solve for A and get 4/3 and put it back in. So there's our final quadratic function. Do the same over here, but this time we don't have x-intercepts, we've got the vertex. We use the vertex formula. So it's this formula here, where the x-coordinate is the opposite sign of what's in this bracket here. Instead of +2, it's -2, but the y-coordinate is exactly that value sitting out there, which is +4. That's the vertex formula, which is A x take h all squared plus k. Now we sub in this point here, 1/2, 0. 1/2 goes where x is, 0 goes where y is. And you work with that. Take 4 over the other side, and then you square that, and then take that over the other side by dividing by the fraction, or multiplying by the fraction inverted. And so we get our A value. Plug it back in. I haven't got room here. Plug it back in and then write the equation again. Now I've got a bridge over a river. The height is 9 meters in the middle, and the bridge has that equation there. How wide is the river? Well, since the vertex is 12, because it's x take 12 is the vertex formula, 12 across and 9 up, that means we don't know where the origin is, so we place it like that, just randomly there, and so it's going to be 12 from here, from the 0 all the way over to here. That's 12. Now how do we know what the width of the river is? We need to work out the 2 x-intercepts, these 2 values here. Now to work out those 2 x-intercepts, we could put y is 0. So if we have 0 equals, and we've got minus, I'll just put here, 0 equals minus x take 12 squared plus 9. Now we'll take this over to the other side, and so we have x take 12 squared equals 9. Now if we square root both sides, we'll have x take 12 equals 3 plus or minus 3. And now we add 12 on the other side, so 12 plus or minus 3. 12 plus or minus 3, you get 2 answers, 9 and 15. So your 2 x-intercepts are 9 and 15. So that's this one here and this one here. Now because they didn't specify that you couldn't use the graphics, you could have got those answers by actually typing the the quadratic function into the graphics calculator and working out what the zeros are. So now the question is, how wide is the river? So now we can say that from 9 to 15, that's 6 meters. So we can say that's 6 meters. However, we've got an assumption there, we're assuming the bridge starts at the water edges. So we're assuming that the water runs from 9 all the way to 15. Whereas in real life, it may be something like this here, where you've got a gap for a walkway on either side, and this, like in 3 dimensions, you'd go back like this. So you've got your walkway through there, and your walkway through here, and your overarching bridge like that. So that's the assumption. Part B, where are all the places that a 3 metre high sailing boat can pass? So 3 metres means you can fit the height, because y is the height, you can fit 3 metres underneath that bridge there. So what we're trying to say is, well, there's the quadratic equation. When does that equal 3? So 3 equals that quadratic equation. I'm going to solve for the 2 places when you get 3, and then the boat can actually go in this region here, that region there, but it can't go outside that region, otherwise the height's too short. So putting 3 in there and solving this, we're going to minus 9 on the other side, so you get minus 6, square root both sides, plus or minus root 6, and plus 12. So there's the 2 places. That's 12 take root 6, and that is 12 plus root 6. So the boat can travel anywhere between those 2 x values. So if this is 12 plus root 6 and that is 12 minus root 6, that means in the middle we've got 12, we know that. So it's plus root 6 to the right, minus root 6 to the left. So it's root 6 meters either side of the center of the river. We could say it like that. Whereas if we say it like this, this is reference to the origin, which is sitting over here. This is a profit equation. So the profit is equal to this quadratic. To plot that, notice the factor gives an x-intercept of 780. This factor gives an x-intercept of 90. This is the number of items made. This is the profit you get from it. The break-even points are when you don't lose money or make money, you just break even with your manufacturing. So that's this point here, and this point here, 0 profit. So the break-even points are those 2. The maximum profit is halfway in between. Halfway in between those 2 is 435. To work out the profit, plug 435 into the n value, into each of the n values, and that turns out to be 89,000 as the maximum profit. When you make 435 items, then you maximise your profit. This one here, we need to find the functions. This has got a x-intercept of minus 4 and 3. These are cubics, not quadratics. It's got a linear factor of x plus 4 because it cuts at minus 4. That makes it 0. This one here, it touches, so it's a repeating factor which is with a squared value, and it's at 3, so it's x take 3 all squared. That's a cubic because we've got a linear times a quadratic. In general, we put an a out the front to have it in general form. And to find that a, we sub in a point which is 0, 9. So 0 goes where x is, 9 goes where y is. If you go through that simplifying procedure, then you'll get a is a quarter, so write it back at the front there. Likewise, this one over here, you've got 3 zeros, so you've got 3 factors. And put an a out the front, sub in at this point 0 minus 12, 0 for x minus 12 for y, and you'll get that a value. Question 10, find cubic polynomials which have these zeros. Now, they've only given you 2 zeros. Cubics have got to have 3. they can be imaginary or surd form. So, but one's got to be in conjugate pairs. So if you look at up here, if it's surd or it's imaginary, it's in a conjugate pair. So up here, they weren't conjugate pairs; they were three separate zeros. But here, if you've got 2 plus root 3, the other one has to be 2 minus root 3. That's a conjugate pair. A bit like in quadratics, you've got to have you'd have to have 2 plus something, 2 minus something if it's a surd form. So we've now got 3 roots, 3 zeros, 1 and 1, 2, 3. So that's what this sentence here is saying, talking about conjugate pairs. Now, to get the factor, the quadratic factor from these two, that'll give a quadratic factor. This one easily gives a linear factor of x take 1, but we don't know what quadratic factor this gives. We could use the sum and product to work that out. So the sum of roots, you add the two together and get 4. The product of the roots, you multiply them together and you get 1. Now, that means a quadratic factor, which is the x squared minus the sum x plus the product, is this here. And so we've got the linear factor and the quadratic factor. That's our cubic. Now it says find all cubic, so we should put an a out the front there as well. So that covers all of them. Notice the other way you could have done it is you could have said, well, since your 2 zeros are 2 plus or minus root 3, then our quadratic factor would be x minus one of the zeros, and the other factor would be x minus the other 0, 2 minus root 3. And then you could FOIL that out. So you're doing first, you get x squared. Doing the outers and inners, we get minus minus the outers, which is 2 take root 3 x, and then the inners is minus 2 plus root 3 x, and then doing the last, you'll have plus and 2 plus root 3 times 2 minus root 3. Okay, so that is equal to x squared. Now, minus 2 is minus 4, and we've got plus root 3 and minus root 3 cancelling out, so that all of that there comes down to this. And then doing the product at the end here, that will give, doing first outers inners last, if you go through that procedure, you'll end up with 1. And so that gives exactly the same quadratic factor that we got up here using the sum and product. Okay, because really it's doing the same thing, because this here, when you do outers and inners, you are doing the sum, and when you're doing the lasts, you are doing the product. And last one is towing an iceberg. The volume remaining of the ice is given by that cubic there, and that's in cubic kilometres, whereas the x value is in thousands of kilometres, and it also has the in terms of x plus 3, where x has got to be between 0 and 4. So in other words, if the amount that you towed was x plus 3, so let's say you towed it for 3,000 kilometres, then what that means is x is equivalent to 0. If you towed it for 2,000 kilometres, then x has to be equal to minus 1, because minus 1 plus 3 is equal to 2. So that's 2,000 kilometres. And we can't be minus 1 because we have to be in the range from 0 to 4. if you towed it for 1,000 kilometres, that's equivalent to x being equal to -2. It's -2 plus 3 is 1. And we can't have that. So that actually says for the first 3,000 k's, it's always going to be the same volume of ice. It's the same as this value here. If we start going bigger than 3,000 k's, so if we go 4,000 k towing, then that's equivalent to an x value of 1, because 1 plus 3 is 4. If we go 5,000 kilometre towing, that's equivalent to an x value of 2, because 2 plus 3 is 5, etc. And the maximum we can go is x being 4, and when x equals 4, 4 plus is 3, so the maximum the towing is the 7,000 kilometres. So we're just going from 3,000 to the 7,000 k towing, and the volume is shrinking during that time. Okay, what's the initial volume of ice? So initially we can say x is 0, which actually refers to 3,000, well that's referring to during the first 3,000 k's of towing. And so if you put 0 into x, you'll just get this value, 7.75. Now that is cubic kilometres. So that's what remains in the first 3,000 k's. What's the volume of ice after, if it's been towed for 4,000? 4,000 is equivalent to x equals 1. So put 1 in, so 1, 1, 1, and you'll get 7.44. So it's shrinking down a little bit more. And if you do it for 7,000 k, that's when x equals 4. So put 4 for x, you'll get 6 kilometres cubed. And the question for part C says what percentage of the original volume still remains. Now to express it as a percentage of the original, you divide by the original, and that's 0.77 or 77%. So it's 70% of the original. Part D says how many kilometres was it towed before it lost 10%. So if it loses 10%, then 90% will be remaining. 90% of the original is 6.97. So the volume formula is how much is remaining. So we need to have that amount remaining equals our cubic function. Now we need to solve for x, and the only way of doing that is going to the graphics calculator. So we can put in this function into y1. That can be y1, and we can put this function, which is a constant value, into y2. Now I don't know if that's sitting here, no, but yeah, you could put that into y1, put that into y2, and you get something like this. Y1 will give you cubic, and y2 will give you your straight line. And so you want to work out when they're going to be the same, when they intersect, and of course remembering that only x can be between 0 and 4, and so it will turn out to be one particular value of these intersections will work, 2.418, and if you add that onto 3, so that's 5.418 or 5,418 kilometres. Okay.